I feel like I want to start with saying that we've seen a lot of agents in the last few years, and in a lot of ways, we've solved building agents. But this talk is not about the first iteration of when you get an agent running in your laptop. It's about how do you really deploy them at scale reliably and sort of up-level the agents that we're building. The reason I'm talking about this, as Adam alluded to, is that I've been building an ML infra for about 5 years, even more if you count the previous company I was doing it at. And at ZenML, what we did was we built MLOps infrastructure and ML pipelining infrastructure for orchestrating machine learning workloads, which, funnily enough, MLOps has a lot of things that are shared with AI or AgentOps. And like having seen that industry play out in the way it has, I feel like there's a lot of things that we could just learn and shortcut in the agent era. So that's what I'm here to talk about. Maybe perhaps we should really start with taking a step back and seeing how far we've come with agents. The capability is obviously real. Like some of the examples here are just cherry-picked. We've been tracking this in the ZenML LLMOps database, so there's a link over there. If you're interested, we have thousands of cataloged use cases. It's also an MCP server if you want to check it out and pull it in your local machine, where we really go through all the published case studies in the world of how agents run. And one thing is for sure real, is that in the last 3 months especially, we've seen a massive uplift of what these things can do. So the capability is indeed very real, at least in some certain instances. So why isn't it really that everybody around us is talking about long-running ambient agents all the time in enterprise? So that's really the question, right? So numbers like these are thrown around a whole bunch of the time. You can take them with a grain of salt. I'm sure some of you are running agents at scale in your companies. But the fact is that if you really zoom out from a global GDP perspective, there's still no real measurable P&L impact of GenAI projects in the enterprise. And like no matter if you want to see how many are in production or if you want to see how many projects have been canceled, so even though we know that there's a lot of capability that exists and a few companies have really up-leveled and upskilled themselves to get to that scale, the fact is that the production infrastructure and the tooling and what's required to operate them at scale really hasn't caught up yet. And that's just a fact, given all the data that we see. And we see that in our own databases with the ZenML LLMOps database that I referred to as well. So perhaps we can dig one layer deeper into why exactly does the enterprise struggle? And I feel like one of the things that's important to understand is the recent progress that has happened with agents, especially in the last 3 months, let's say roughly around the New Year's time, and then OpenClaw, has largely been driven by longer-running agents which have worked autonomously. You can see this in the meter, like one of our favorite metrics to look at is how long can an agent do a task with a certain probability of success, and how long does such a task take? And you can see that that's growing exponentially still. So this curve, I've been talking about this for around 1.5 years, and it's been steady. So it's very predictable how that goes. But the thing is, these long-running agents, what we've discovered recently is most of them are software agents, coding agents. So I'm pretty sure all of you are using coding agents. And the fact is that coding is sort of an expression of math, which is a representation of reality. And if you zoom really out, you can see that you can achieve a lot of tasks with code, expressing code, that you normally wouldn't associate perhaps directly with code. So for example, if you want to build a presentation like I did, so this presentation is built through Claude Code, you can do that with code. So the agent should write code, it should execute the HTML, and then deploy it, for example. There's many other tasks that you wouldn't necessarily have associated with code directly, but we found out through harnesses like Claude Code that actually these general agents tend to be very good coding agents. So that's just one thing to note. These longer running agents tend to be very good at coding. LLMs are very good at coding. and that generalizes. And then what seems to have happened is we seem to be coining terms every few months in this space. There has been a collective realization that, oh, it's not the model that's driving that advancement, it's the harness, right? What is the harness? Well, I'm pretty sure if I talk to every one of you, the definition might slightly vary, but let's put it this way. If there's a while loop where you ask an LLM something and it says execute a few tool calls, then the system that actually executes those tool calls manages the memory, does the context engineering, does all the things that OpenClaw was very good at, for example, is what we're collectively referring to as the harness. Let's simplify it accordingly. And you can see that since November, we've been talking about this a lot. And like one thing I found very interesting was actually this, a research engineer by the name of Chan Boluk, who actually got from 6.7% accuracy to 68.3% accuracy in his coding tasks by building just a local coding agent. And all he did was he changed the edit format of the harness, which he didn't have control over when he was using Claude Code or GPT Codex, which is a very interesting example of how you can make now very simply your own personal harness that optimizes for your task. And it can give you massive, massive gains. And you can see this with OpenClaw, right? The acquisition of OpenClaw, or I saw Moltbook was acquired a few hours ago. That's by Facebook. So there's obviously a push from a lot of the foundational models labs to go up the stack towards the harness. So, which sort of reminds me a little bit of the bitter truth, like the bitter pill to swallow. If there's anything we've learned in the last 3 years of agents and LLMs, is that the foundational model tends to consume a lot of the harness as we go along, because the model labs are doing their evals accordingly. So for example, last year, if you were talking about fine-tuning for tool calling, now you don't need to do that anymore because the models have taken that over, and they're very good at tool calling now. So what I started thinking about recently is we're sort of in this loop of we constantly have to rewrite the harness because the underlying layer gets better and gets consumed into the harness. So I like the example of Manos, for example. Manos had 5 rewrites of their entire harness in 6 months because every time the new model came out, they had to rewrite that whole assumptions they made because they just went out the window. We had like similar thing with deep agents, with LangChain, where Cell, they just realized if they took away 80% of their tools in their harness, it just got better. So really, I think the lesson to learn is if you over-engineer the control flow of the harness, you might end up losing because the model just will get better and might eat up all of your assumptions. So if anything, one thing you should probably take away from this talk is the prompt structure, the control flow, the tool formats. You might want to innovate on them and learn about them and tinker. But really, you should expect the model providers to get a lot better as time goes. So you might not want to innovate on that. But here's the thing. That is not the only thing the harness consists of. And this might be controversial. But for me, there's a model-facing layer of the harness. So imagine the model layer is the thing that interfaces with the model, the thing that manages some of the context, some of the assumptions you made about around tool calling, how you do tool calls, how you do the message formats. Those things are probably things like recursive language models might eat those things up. But one thing I can almost guarantee that won't get eaten up is the infrastructure layer, so the world-facing layer, the thing that goes when you actually deploy the model outside of your local machine. Right now, I think we're very used to running Claude Code in our local machines, and for us, this is a huge win. And that's fine, because I think that already up-levels so many people, and Claude Code is not just a coding agent, it's a general agent, as we've learned. But where the world is headed is pretty obvious. You don't want this tied to your machine. So you don't want, if I close this machine right now, your agents and your sub-agents just stop. So you actually want to get it out of your machine into some other system, and then you want to have a system around orchestrating all of that. And really, I think that system has gotten is probably pretty underdeveloped in the agent world. So that part of the harness is probably something you could innovate on and could invest in as leaders in your company, because I think that's going to be increasingly important in the next few years. So if you want to run a fleet of agents, it doesn't really scale like linearly. So it's very easy to go from one agent to 10 to hundreds to thousands, because it just makes sense to scale it that way. You have companies like Spotify, Stripe, and Cursor doing this already. So it's fascinating to me to see Stripe is merging thousands of PRs, which are purely developed with agents, which are running in an ambient environment. It's like background agents. They're not running in a local machine. They're driven through events that are sourced and are running at scale, and it's really working in production. So what ends up happening is it comes back down to the fact that this is a distributed systems problem. You have to manage lots of microservices, which are stateful, and you have to do this at scale. And you have to make sure that it's robust and reliable and execute things exactly once. So how do you actually build this layer? What are your choices as enterprise leaders or in your company to build this layer? So I think there's really two choices you have. We have option A, which is you build it yourself. Stripe did it. Perhaps you can as well. And the other option, which I feel like is pushed with the model foundational app companies, is they're hiring FDEs. So they're sort of hiring forward deployed engineers because they know that their harness needs to be deployed onto some infrastructure that's bespoke to the enterprise, and they want to take that back into their company. So they're incentivized to do that. So I believe they hired 800% more forward deployed engineers, I'm talking about OpenAI, in the last 8 months than they did the 8 months before that. And that's going to keep increasing. But the fact is that when these FDEs go home, who maintains and builds this layer? So my instinct is, having seen this story before in the last 5 years in MLOps, is that you sort of need a function inside your company that owns the internal platform that orchestrates these agents. Because that knowledge, you would be astounded at how much gain and how much differentiation you can make with your competitors if you have a function that's dedicated and built into that. And I'm pretty sure in the future, or even if it's not happening today, AI platform layers that handle those things are going to be built bespoke in a lot of enterprises, like Stripe did. Cool. So good news. We have multiple decades now of cloud compute and knowledge from the world of DevOps, then MLOps, now we're going towards whatever ops. There's a few new primitives which I'd like to highlight. So I think orchestrating agents, perhaps durable execution is more important. Observability, things like brain trust or Langfuse or just OTel traces are important. Governance, identity. But the two things which are pretty much unique to agentic workloads on the infrastructure side are perhaps the memory side and the sandboxes side. So if we believe in the fact that agents which are good in general purpose are good coding agents, then probably you don't want them to execute arbitrary amounts of code in their local host machine. So things like Monty, like from the Pydantic team, or things like Daytona or E2B are getting increasingly relevant. And this is why you see a lot of funding going into that, because it feels like that's a central primitive to enable ambient agents that run autonomously for long amounts of time to execute code in a safe way. So these primitives right now exist almost in silos. And they're not being talked about in a composable, easy to grok way. And this is my appeal to everybody here today, that we should probably, as a collective industry, start talking about this problem. Because we've done this with MLOps. We had so many things like feature stores, model registries, experiment tracking, deployment targets, central ways of standardizing what a model was. We don't have any of these things for agents right now. We don't have a central place of serializing an agent. I know the Pydantic team is trying, and we should support them, especially in open source. But there's so many things around standards that we need to build that probably build on top of the previous standards that we'd already built. So my appeal to everybody here today is let's collectively start talking about the infrastructure layer of the harness more than just the other model side layer, which seems to be dominating social media. So if I was to sum it up, the model is going to be an API call. The framework will probably get replaced, but the infrastructure is the only thing that will compound and is probably worth investing in today in 2026. And a small announcement, so this is a little plug. So because we've been thinking about this for so many years, we're actually building a tool that is taking all of the knowledge we had with MLOps, with ZenML, and we're working on making a composable layer for building your AI infrastructure layer in a composable stack inside your enterprise. If you're interested, we're looking for early testers. This is very new. So the project's name is Gitaru, which means to arrive somewhere in Japanese. And there's a little QR code at the bottom right here, or even here if you want to scan it. Or you can just grab me in the conference floor. I'd love to talk about the primitives of building the next generation of AI infrastructure platforms for agents. Thanks for your attention. Thank you.
Do we have questions for Hamza?
You drew the analogy. I'm Sudhir from Hydrotrek. You drew the analogy with microservices. And then if you think about microservices, Kubernetes, orchestration, and it kind of grew up from. But the microservices, when they talk to each other, they're kind of pre-wired endpoints and application protocol in the 7-layer stack. We don't seem to have any standards on the, I mean, I haven't looked at deep into agent to agent. But if you could talk about where you see it going with agent decides on the fly to, I need to talk to these other agents, and that knowledge, therefore, can easily talk to the authentication, authorization, all the other issues that we orchestrated, virtual machines and all that, they're kind of back up again. But there seem to be any, apart from your talk, I haven't seen discussions that are focused on that. So if you can talk about that, that'll be great.
Yeah, I mean, it's a great question. The primitives we need, the standards we need to build, as you said, are quite new. So things like agent to agent, and even if you look at things like MCP, are probably good efforts in that direction. I haven't seen A2A really take off in production, although I've seen some of our customers use it. I don't know whether that is the end-all and be-all of communication protocol between agents. But one thing I do think is wrongly categorized a lot in infrastructure world is that agents are just microservices. Because in many ways, microservices are built to be stateless, and agents are very stateful by design. So there's a context, there's a memory that you need to preload into them. And also the latency requirements and things like that are quite different in agents. Because, I mean, if you think about it, if the LLM takes multiple seconds to think about something, it doesn't really matter some of the assumptions we had for running 150,000 transactions for durable execution for microservices. So again, we're very early. I don't know what the protocol will be, but this was sort of my attempt at trying to motivate this sort of discussion, because, as you said, I haven't seen enough of that. But I do feel like whatever we're going to build on is probably going to be shortcutted with the 20 years of experience of running microservices at scale with just classic software. So I'm very looking forward to the time we standardize that.
Thank you for the great talk. I think you accurately described some of the key pillars of building agent infrastructures. The sandboxing space is interesting. There's not a lot of open source projects. I've been thoroughly reviewing, seeing what's happening on GitHub. There are different patterns also. Do you run your agent inside a sandbox, or you have an agent running somewhere in a central place and using many sandboxes? Are there things that you've experimented with that you want to share, like early findings, and what do you think will happen in the sandboxing space?
This is a very good question. So there is no, I feel like there's two patterns, right? Either you run the agent within the sandbox, and then, or either you give the sandbox as a primitive, as a tool to the agent, right? I was yesterday at the Daytona Compute Conference where I had conversations around this, and it feels like the pattern is 50-50. So sometimes it makes sense to run the agent itself in the sandbox. Sometimes it doesn't. I don't feel like that's something we should worry about too much because it's probably always going to be dependent on the use case, and probably you might want to mix and match. But one thing I am really interested in nowadays is sandboxes comes from the world of infrastructure, which is ephemeral. So most of the sandbox services, for example, don't run sandboxes more than 24 hours. And they're just designed around that. And now OpenClaw sort of taught us that we don't need ephemeral instances. Perhaps we just need a computer, a real computer for this thing with a real identity attached to it that's just doing things in editing state on the fly, and you want to give it more powers, right? So for me, the pattern that I'm not sure about yet is whether we are going to be innovating on having ephemeral storage for sandboxes that just takes snapshots from the memory and from the file system in such an efficient way that that just becomes trivial, so you can just fork and do replays and all that, or whether we're going to gravitate as an industry towards these like fully Mac Mini sort of setup where you just buy it and it's just there and it's just running. So I'm not super sure about that pattern yet. I think it's still emerging. Thank you so much for your attention, everybody.
Let's thank Hamza again.